Hello and welcome to this week's What Were They Thinking? Among the variety of news items we have for you, claims of a Russian cancer vaccine and possibly how, let's say, overblown they are. A kissing bug is spreading in the US and the CDC has felt it necessary to warn us. Cannabis has been linked with chromosomal abnormalities amongst IVF babies, and there's been a copyright settlement for Anthropic's use of, well, rather obviously, the copyrighted material. While it's not exactly ideal, the settlement does set a precedent for other large AI companies. These and other news items can be found in the timestamps given below. Let's start with what is arguably the most promising news, and also the most unlikely news. Russia's supposed cancer vaccine. Now, we're not going to say the idea is impossible. We are going to say that, given the extreme complexity of what cancer is, even the currently available sort of vaccines only target a single individual kind of cancer, and even then, results can be mixed. So this new vaccine, called Enteromix, having completed preclinical trials demonstrating safety and efficacy, sounds like it might be great, but the lack of detail is the problem. So, let's start with the what, why, and how, moving on to the unlikeliness of it all. The first thing is the vaccine requires multiple ongoing doses, so it would appear that this is an ongoing treatment, not a singular treatment. Very much similar to, say, the prostate cancer treatments that are intended to slow down, let's say, the progress of the, obviously, prostate tumor, which prevents it from turning into cancer, given the difference is that a tumor is at least an unwanted growth and can interfere with organ function, mostly here about the vas deferens, and later on the urethra, but a cancerous growth is something that actually causes problems.
You ever stop and think, wow, I'm married to that guy?
Nah, I just repress it.
Is that healthy?
What's the worst that could happen?
I'm a tumor, I'm a tumor. I'm a tumor, I'm a tumor, I'm a tumor.
So this is the first, let's say, caveat. It's not necessarily a, let's call it a treatment for cancer. It's a treatment for a cancer from the sounds of it. And the initial information that is available from, let's call it, less than reputable sources says it targets colorectal cancer, which, again, sounds good. Mostly because, well, colorectal cancer is rather more, let's say, prevalent at the moment than most people are comfortable with. Aging populations, but also, strangely enough, in younger individuals. So, this brings us to some, let's say, less helpful details. The data that has been released to date is relatively, let's say, poor quality, to be polite about it. And so, the ability to actually analyze what's going on is very much limited, mostly because, well, the Russians are very tight about what they're talking about.
No, it isn't ready. It hasn't been tested. We don't even know if it works.
If what works?
The preclinical testing also indicates animals only at this stage, which means there's a whole bunch of bunnies, rodents, and so on that are basically being given cancer and told, okay, we're going to treat you now, which sucks for them. But it's a necessary evil before you move on to humans, and arguably it also means that the moment they move to a human study, this may have zero efficacy whatsoever.
Do you think wildly erratic emotions could be a residual effect of the energy patch?
Hard to tell. This is the problem when the company will only pay for testing on drunk frat guys.
There is a very, very limited success rate when it comes to transitioning from animal models to humans, and we would say it's less than 0.1%. And that's just getting the initial success, let alone ongoing success in later levels of trials, which drop off even more significantly again. Even if the, let's say, claims that these studies are in a phase 1 trial, it still means very little. Mostly because phase 1 trials do not look at efficacy, they're looking at safety. You essentially get a whole bunch of drunk frat guys, pay them $50 and say, okay, we're going to inject you with this now and let us know if you feel anything funny. Well, no, it's a little more complicated than that, but that is the gist of it. They're not actually looking to see if it cures cancer, in this case slows it down. Rather, they just want to know, if we give you this vaccine, will it kill you? Ideally, not that extreme, but there are often many other different complications that could occur instead. For example, is the site of injection going to suddenly have massive edema and become unusable? That's a problem. Is it going to cause a secondary effect such as activating the immune system in a way that it causes autoimmunity? There are plenty of ways things could go wrong, which is why they start only with safety and not efficacy. This is also arguably why drug trials tend to pay reasonably well. There's a relative level of discomfort and some level of risk that you're basically paid for up front, assuming that they've not screwed up spectacularly and there's an actual liability case to be made. If that happens, there's an entirely different issue at hand. Moving on to less useful news for the most part, but certainly more real news, we have a new form of diabetes being officially recognized. This is called type 5 diabetes, which isn't all that helpful because now we have type 1, type 2, and type 5. The difference that this has from the first two is that type 1 is where you have no, or at least drastically reduced, insulin production from your pancreas, and therefore your body can't function without exogenous or essentially injected insulin. Type 2 is when your body typically becomes more resistant to insulin, and therefore you basically need to either amp up the amount of insulin you consume by injecting it, or by dietary changes. Either option will achieve similar outcomes, and sometimes you'll need to use the two treatments conjunctively. Type 5 is, obviously notably different again, and this is where we need to talk about what is relevant here. Mostly here we're talking about a malnutrition-linked type of diabetes. Understand, we are skipping over things like gestational diabetes and similar. Although recognized as distinct, we can ignore those for now to understand what makes type 5 special. Type 5 diabetes is, to be blunt about this, a poor country problem, and to a lesser extent, a poor person problem. Yes, that sounds harsh, but understand me, hear us out. People who have low body weight will not produce anywhere near as much insulin, because they're not making insulin. Let's be blunt about it. They're simply not able to respond to sugars the right way, and their body doesn't quite develop the way it should do. And this is very important during early childhood, where the pancreas needs to develop properly. Otherwise, when you get older, you basically are in a shit show of your body's not equipped to deal with everyday encounters. Mostly animal research has established that this can happen, particularly if you have, say, a low protein consumption during pregnancy or adolescence, and in some cases, if you have a protracted period where this is also true. To be clear, this doesn't necessarily need to be meat-based protein. You can get it from other sources, which does explain why some countries, despite seemingly having almost no meat consumption, still have a relatively lower profile of type 5 diabetes. It's because they make up for the lack of meat-based protein using other sources. This is admittedly a useful thing to know about, but not really relevant in a lot of contexts. That is assuming you're not in, say, a developing country, in which case, yes, obviously, or having to, say, work in medical services in a relatively, a low socioeconomic community. So, effectively, either the downtown area of your nearest major city that's highly questionable, or simply, backwaters of some country, which, again, the same issue, just slightly different again. We now have to talk about actual diseases, because diseases are always more fun, and in this case, it could actually be caused in part by fun. It's a, kissing bug disease on the rise across the USA, and the CDC is ringing alarm bells, which, last time it did this about measles, nobody listened, and now America has measles everywhere. Also, they have RF cray-cray, but that's sort of related but also separate. The kissing bug disease is actually a parasitic organism called Chagas. Chagas is something that hundreds of thousands of people are already very likely infected with, but only 29 infections have actually been confirmed, at least between 2000 and 2018. Since 2018, the number has gone up. It's gone up by at least 30%, if not arguably more again. While we won't exactly say we're in 100% agreement, the pattern that the CDC describes does at least hold. That is, as you see global warming, there is a shift in the environment which is most suitable to the carrier of Chagas, that being kissing bugs. And as a result, well, you basically see it moving ever further north in the USA, and presumably south in the southern hemisphere, but the data we have, at least for now, is relevant primarily to the USA and the continental USA. It gets a little more complicated again though, because, well, pets and to a lesser extent wildlife act as an excellent reservoir of this disease, Chagas.
Excellent.
And as a result, you can basically get infected, or infected is perhaps not quite the right word, but it will do, through contaminated food, various animal products, and even organ donations. And then the mother can pass on the parasite to their unborn babies, meaning that you may not even be aware that you're infected, you may inadvertently infect your child, or in other cases, your pet may infect you due to exposure. There are all sorts of ways. And, well, if it's not treated, the parasite can settle into a person's heart, digestive muscles, and more, causing all sorts of unwanted damage. Or at least we assume unwanted, unless you're feeling particularly self-loathing. But that's a different matter entirely. Moving to news that we would almost not stand for, except for the fact it's at least mildly interesting. An argument that caffeine in your blood could affect body fat and your diabetes risk. First of all, caffeine is life. It is essential to being able to function. We will stand for nothing that speaks badly of the importance of caffeine. But the research is at least focusing primarily on things that are reasonably true. And true in terms of actual research has already established some of this stuff, but as we'll explain, this provides more direct and somewhat more comprehensive detail. First of all, they're primarily looking at caffeine in your blood initially, because rather obviously blood circulates around the body, from the body it goes to various organs, tissues, and so on, meaning that it will basically get to everywhere. If you have let's say a higher plasma caffeine concentration, you are more likely to have a lower BMI and a lower whole body fat mass. Essentially, you weigh less. Let's make this easy. Further to this, the genetics of an individual could actually predict whether or not they had higher plasma caffeine concentrations. Further to that, those same genes and various gene associations were associated with a lower risk of type 2 diabetes. You could argue that about half the effect of caffeine on type 2 diabetes was essentially reducing that risk. So you could also attribute that partially to a reduced BMI as well. So together, the fact that you weigh less and you have a lower risk of type 2 diabetes from caffeine means you've basically halved the danger of becoming diabetic, at least later in life. Now, this, of course, assumes you're not an American, and therefore not only consuming an inordinate amount of sugar, but also weigh the same amount as a very small car. The study is stronger, let's say, for the fact that it has about 10,000 people, and the limitation of that, though, is that it relies on an established genetic database. So this is a hit and miss situation. Some things are good, some things are bad. But again, simply because of the size of it and the data available, you can get a good idea of associations. Not necessarily causality, mind you, but definitely an association. There's also the fact that a lot of the people who were involved in this study were reporting on their own behaviors, and inherently people will report their behaviors in a way that is, let's say, most likely to make themselves look better, which, okay, if you consume 10 cups of coffee a day, what difference does it make if you, say, make only 5, and so on, or what about if you just knock off a couple of kilograms from your body weight? All of these sorts of things fudge the data a little bit, but it is at least a good broad indication of what's going on, and it's certainly supported by prior data from other studies that are more direct and literal. As a result, we can say that this is really only supporting our argument that people should be consuming coffee in inordinate quantities, and we should make every effort possible under the sun to ensure that coffee continues to flow freely. Moving now to research into something somewhat more relevant, but also again very limited, we have Canadian IVF research looking at the use of cannabis and the fact that if you are consuming cannabis, there's a good chance you will have a more difficult time, let's call it, in getting pregnant. The short answer is that looking at about, little over 1,000 people of, let's say, cannabis-consuming nature and follicular fluid taken from them during the developing stage of eggs, they found that, a surprising number of them, about 600, were positive for cannabis to start with, but also those oocytes, or egg cells, with association to higher cannabis use were likely to have chromosomal abnormalities, which reduces the probability of a successful pregnancy by a lot. Of course, this is not to say that it's the sole causality of this. Obviously, there are certain patterns when it comes to cannabis usage, mostly that those who use cannabis more frequently tend to have, let's be blunt about it, socioeconomics for them are not the best. But then again, this is not true across all strata, all societies, etc. So there are definitely caveats in saying that, but there is a reason why, typically speaking, cannabis use tends to be more prevalent in certain demographics. So we have, obviously, a problem with IVF then, and the question is, what about just regular sex and trying to get pregnant that way? Well, we don't know. They didn't answer that question. So, damn. There's also a whole bunch of other research that they've done, but the pattern is the same, along with the limitations. A variety of extraneous factors that could be confounding this, such as the age, the various other factors. Let's just say that for now. It's easier to describe it with a simple summary. As a result, if you're looking to get pregnant and you're going to undergo IVF, consider putting down the joint, at least until after you've had the baby. Moving on now to another study looking at the same region of the body, or very close to. It's that your toilet time may increase the risk of hemorrhoids. A toilet time also ironically being let's say, a euphemism for spending time with a chatbot in China. Literally, talking to a chatbot while on the toilet, although in the case of other countries it's more likely to be social media, where you spend an inordinate amount of time doom scrolling. But that doom scrolling, other than being terrible for your mind, may actually also be terrible for, your ass. There's a 46% increased risk of hemorrhoids, this being swollen veins in your rectum, due to, pushing or squeezing too hard. And to be clear about it, this issue is not going to change regardless of your age, sex, BMI, exercise, fiber intake, or a lot of other factors. Quite literally, you just spend too much time on the toilet with your smartphone doom scrolling, and suddenly your ability to poop properly is going to be challenged. And it's important to remember that hemorrhoids aren't fun. Well, obviously they're not fun. They're kind of shitty. Well, no, actually it's the other way around. It's the fact that you're trying to shit that is the problem. So, the study does have some very major limitations. Let's be very clear about it. 125 participants who received a colonoscopy were surveyed. 40% had a hemorrhoid and 93% they had used their phone in the toilet at least once a week. So, the results aren't that compelling. Although we do find it weird that about 30% were emailing or texting while on the toilet, while 44% they are on social media. This raises two very big questions for us. Who sends an email while they're pooping, and what were the other roughly 30% doing that weren't on social media or trying to somehow communicate? So this is going to be, let's say, interesting, but ultimately it doesn't change a lot for most people because there's a good chance they're still not going to change their behavior even knowing that they have a greater risk of hemorrhoids. What may, and in a very vague sense of may, change their mind is a study coming out of Stanford. And what they've done is, thankfully, not another Stanford prison experiment because that ended spectacularly last time, and it's basically become a learning example for every other student since that you don't put a bunch of people in power and let them abuse the crap out of other students. No, instead, you let other people online, particularly social media, abuse people randomly, and that not having that happen by not being on social media could be very good for your health and well-being. There is an ongoing, let's say, proposition that since about 2010 and the drastic increase in social media, people have become increasingly anxious, leading to the development of an anxious generation, and kind of yes, kind of no. But if we ignore that particular issue for a moment, we can say that social media in general terms is not great for people. Constantly being exposed to other people's success and your own seeming relative failures, because you either aren't posting the same awesome crap, or you're just constantly seeing other people awesome crap and you're comparing your life to it, isn't great. As a result, however, people aren't feeling good. So what if you just turn off social media? And that's what they've done in this experiment. They offered individuals a rather substantial amount of money to just give up on social media for quite a while, and, well, it seemed to work. We should, however, point out that the study does have a fairly big, let's say, limitation to it that we do need to point out. What the authors have done is take individuals and they had them stop using social media, particularly Facebook and Instagram, for the 5 weeks before the 2020 presidential election. This is very important because, obviously, given this is a United States of America study, the implications of not having access to social media leading up to a presidential election means that you're not going to have as, let's say, significant an idea from what others are saying about, well, particularly the election, which is a substantial event. So that's definitely a, let's say, a confounding variable. The next factor is, well, obviously, social media is not just used to watch people's posts and doom scroll. There are other communication aspects to it, but assuming that individuals, rather than using social media from the social media aspect and stuck only to messenger applications and similar, probably okay. Then there is the fact that, well, people spend a lot of time on social media and they haven't established a dose response exactly. They've basically established some sort of correlation, but not causation. And finally, well, as in all effect, the mental health, although worsening in America, particularly since 2004-2005, the, let's say, causal link isn't quite there. But then again, their experiment seems to have kind of demonstrated exactly this. 1,600 individuals were involved, and just a bit more. They had to, well, just ignore social media, and this made people less informed about news, less politically polarized, and happier. Which, no wonder. If you aren't constantly being exposed to crazy shit, you're probably going to be happier. Moving on now to other technology news, although this time all about AI and the fact that Anthropic copyright settlements have been reached. Anthropic being an AI company, and they're responsible for Claude. They've agreed to a $1.5 billion settlement, but this has now two issues to it. First of all, basically those involved are going to get at best $3,000 out of it. And that assumes you have a book that they've used, which would be the subject of this lawsuit. If you don't, you basically get nothing. If you have more than one book, you will obviously get more money, let's say. The second thing is, though, that it raises the cost for other companies now looking to, well, use various publications. The settlement isn't exactly a precedent, but it also sort of is, as it makes clear to other AI companies that, look, if we're being sued, we are better off just settling this claim and making it go away. Whether or not it will cost them $3,000 per copyrighted work, or more, or less, is another question again. And there's an entirely a possible option here that some, let's say, copyright owners may, rather than choosing to settle, pursue the case and get an actual court decision that will set precedent. And from there, AI companies have to panic even more. But for now, we can more or less assume that any AI company out there, whether it's Grok, ChatGPT, and so on, will now have to consider paying out at least $1.5 billion to various rights holders, plus legal costs and so on, just to continue operating. And that's if things go well. Of course, the other issue here is that the judge is still not happy with the decision, because they aren't clear about the actual terms of the settlement. So they've asked for the clarification to be provided and to make clear what exactly is going to be done. The consequences of this are, well, fairly obvious, that if you are using a paid version of an AI, you are likely to need to pay more in the coming future, as companies look at this and go, well, if it cost us $1.5 billion to get this thing out there in the first place, we need that money back, and the only way to get back is to make the users pay through their, well, we would say arse, but apparently that's what you do in the toilet, which, presumably, given the Chinese pattern of using AI in the toilet, it might actually be possible. Anyway, the probability of a price hike is significant. Of course, things do get a little bit worse if you're using AI because, well, strictly speaking, this could be seen as a win. More so if you're a copyright holder. The win for copyright holders is they're going to get money, but if you're an AI company, well, this is a fairly small amount to pay for what they've been able to do. Admittedly, it's a lot of money, but for what they've done, it is very little. Remembering that, given the nature of what they're doing, which is essentially copyright theft, they would be paying a lot more for what it is. A lot more. Because not only would they have to pay that $3,000 for the copyright element, but also licensing costs and so on. And that is where things get to be very expensive very quickly. So AI could see this as a win, and copyright holders see it as a not quite a loss, but definitely not a win. And going on to animal news, because, well, strictly speaking, that's the next thing for AI to do, is to become some sort of living organism. We have evolution, and for some reason, animals are diverging in two particular ways. To be clear about it, this is a, let's say, limited study, mostly based on archaeological sites, but what the study in France identifies is that there is a common denominator, humans, and humans are driving wild animals to get smaller, and domesticated animals to get bigger, at least over the last 1,000 years or so. The driving force of this looks at about 81,000 physical measurements of remains collected from 311 archaeological sites, and they found that, obviously as mentioned, domesticated animals, chickens, cattle, etc., get bigger, wild animals, foxes, deer, and so on, got smaller. The researchers took this information and modeled it across a variety of environmental factors going over about 8,000 years. They allowed for things like climate, vegetation, human land use, and so on. And, well, yeah, wild animals get smaller, unless they're adorable like a bunny, in which case they somehow got slightly bigger, although only marginally so, and domesticated animals, well, got bigger full stop. So it's clear that humans are very much affecting the environment around us in ways that are not necessarily negative so far, but definitely in terms of, well, let's be clear about this, very unexpected. Moving now to news in space, or at least probably going to space, we have a microbe that can not only eat the dust on Mars, but as a result make oxygen. This could well become a pet, and although we make a joke of our sourdough starter being called Mr. Bubbles, we don't actually consider it a pet. However, this is somewhat in that vein of, let's say, thought. It's an extremophile form of cyanobacteria called Crocodilodoptis, and yes, we have completely bastardized that name, but, well, we don't have the ability to pronounce it in anywhere near the correct way. The, let's say, well, let's make it easy, let's just call it a cyanobacterium, is native to the desert and can be found in parts of Asia, North America, and even Antarctica. And given its characteristics and places it survives, it is very resistant to all sorts of nasty aspects. And also, being a cyanobacteria, it produces oxygen. In order to see how well it works, the species was sent up into space. And in the harshness of the open void, or close to, they were trying to figure out how well it would survive, and, well, they did survive incredibly well, about 18 months or 1.5 years. The survival rate, let's call it, could be extended by using biofilms, and, well, the biggest threat to them is simply UV radiation. The same thing for humans. Sunlight will kill us if we're exposed to too much of it for too long. If you give them even a small amount of protection, though, these cells basically just keep on going. If you were to, say, for example, put these under a nice big rock on Mars, well, suddenly they have all the protection they need, and they are able to keep on producing. The scientists believe that between DNA repair mechanisms and the ability to function, the cyanobacterium could be an incredibly effective way of making Mars not just habitable, but very importantly, making it habitable for humans, and possibly, as we mentioned, creating a weird pet. In similar Mars-related news, and the last news item we have for you this week, we have data from the Perseverance rover. Perseverance has been able to find very limited evidence for the possibility of microbial life on Mars. Most of it has been what could be kindly described as, let's say, anecdotal or vicarious proof, but nothing definitive. this is where the Chagas Falls could be exactly what we need. These are part of the Jezero crater, and this is a vast basin once filled with water, theoretically anyway. And here is where things get, let's say, messy. There was, let's call them results, that indicated a compelling chemical signature for very, very ancient life. And so, analysing it, there was, well, organic, carbon-rich material, which is always a good start, but there were also a lot of non-biological processes that could have done the same thing. However, these non-biological processes were sort of counteracted by potential biomarkers that were present. So we had to ask, which is it? And the answer is, well, we're not entirely sure, but Mars is, messy, let's call it. NASA is confident in saying that possibly life, others not so much. And by that we basically mean there are people out there saying, okay, that's cool, but it proves nothing, which is definitely true. There is zero definitive proof of anything at all. But, of course, this being basically ancient life, if it's anything, and if it's not life, it's only ancient archaeological and geological formations, we basically have to go and say, well, how much evidence is enough? And, well, at the moment, there's nowhere near enough. But it's certainly, let's say, a shocking discovery if it's true, and if it's not true, it's kind of interesting, but that's it. That's all the news we have for you this week. Thank you for watching. If you found it interesting, consider liking, sharing, and subscribing, and please do post any comments, questions, or suggestions you have below.